Hello friends, welcome to EC Academy. In this lecture, let us understand the DFT. DFT is nothing but discrete Fourier transform. So DFT is nothing but discrete Fourier transform. Discrete Fourier transform is a mathematical technique which is used to analyze the frequency content of discrete signal. So discrete Fourier transform is the mathematical technique which is used to analyze the frequency content of discrete signals. If we take a discrete time signal x of n with length n, for this sequence, if we take DFT, so DFT of x of n, we can write it as x of k. So for a discrete time signal x of n, which is a finite duration signal, which means this signal is having length n, if we perform DFT on this signal, we'll obtain x of k, which is a DFT of x of n. So mathematically, we can write x of k is equal to summation of n is equal to 0 to n minus 1 x of n multiplied with exponential to the power of minus j 2 pi by n k n. So this is the representation of DFT of signal x of n that can be written as summation of n is equal to 0 to n minus 1 x of n exponential to the power of minus j 2 pi by n k n. Here the value of k is ranging between 0 to n minus 1. So x of k in the mathematical equation is the DFT of the signal x of n, which represents the frequency spectrum of the signal, which means x of n is represented in time domain, x of k is represented in frequency domain. X of n is the input signal or input sequence which is in time domain. Capital N represents the total number of samples in a given signal. K is the frequency index which is ranging from 0 to n minus 1. Small n is the time index which is also ranging from 0 to n minus 1. Exponential to the power of minus j 2 pi by n k n is the complex exponential that represents the basic functions of transforms. So x of n is the finite duration sequence for which if we perform DFT, we'll obtain x of k, which can be represented as shown in this mathematical equation. From this DFT, if we perform inverse Fourier transform, we'll obtain the signal x of n. So here you need to remember that DFT is widely used in signal processing, communication, and data analysis. This DFT is computationally efficient when it is implemented using fast Fourier transform, which is commonly known as FFT. So here you need to remember the discrete Fourier transform is widely used in signal processing, communication, and data analysis. This DFT is computationally efficient when it is implemented using fast Fourier transform. So this fast Fourier transform we will understand in our future topics. This is about discrete Fourier transform. Hope you have understood the topic. Thank you.